Now, I believe this is question 9, or at least my version of recollecting question 9. Does it look about right? The one we left off last time? Let's assume it is. It's certainly similar to it. So we're going to do this fella. And they gave us 4 coordinate points and it made this shape, which I think they called a trapezium, which is fine. And this is the u and the v. The u is y minus x and the v is y plus x. And that makes this top guy u, makes that bottom guy v, which is fine. If you find the Jacobian of this guy, so I guess I should do it. If u equals y minus x and v is y plus x, then the Jacobian is going to be this fella. And it's basically numbers. That guy's going to be -1. No, yeah. And this guy, oh, wait a minute. Whoa,
It's linear, isn't it?
it is, it's linear.
So you'd be able to just do the shortcut?
The shortcut, exactly. So, I can do the shortcut, which basically means you find this answer, right? And then you just do a reciprocal of it. Otherwise, I'm going to have to turn this thing by solving it for x and y, and that's a pain in the butt. I could do it, but I don't want to. Right, differentiate this guy with respect to x, then you do it with y, then you do it with x, and then you do it with y, and you get -2. So the shortcut for this fella ends up being -1/2, which is where that comes from. That's 5. Cosine 5y minus x gets you 5u, y plus x gets you 5v, that's that. Do you remember that when this is a number, you use the positive value of it? So that's going to become 1/2. So far, so good. Now, the region, which is what this mess is about. There's so many little stages, it's almost like you should do them in separate bits of paper. You know, like do that bit in a bit of paper. This is the 4 points plotted. It makes this trapezium red shape. This is the original region R. We're now going to convert it into the S. So here are the coordinates of the XYs. If you use these 2 substitutions, this is what U and V become. If you draw those points, it looks like this region here, which is just a different looking trapezium. And we have to try and describe this region in terms of U and V. And the way I decided to do it is by going this way. So V goes from 5 to 6. This line is y, V equals U and V equals -U. And if you switch them around, U is -V and U is V. So basically, I described this boat shape by doing a horizontal line from this guy to this guy, which generates these 2, and then from V equals 5 to 6, which generates those 2. And a whole load of pluses and minuses floating about. Actually, I think I did a better picture of that. So right now, we have V equals 5 to V equals 6, which is from here to here. And we have U equals this guy to U equals this guy. This line here is U equals V, and this line here is U equals -V. And we have a 5. We have the Jacobian, which gives us the 2. We have the cosine of 5u over v, and now we can do a du dv guy. Let's take it one more step. Let's do this guy. here. And I'll try and make sure I get it right this time. It's 5 over 2, the sine of 5u over v. And what does that, with respect to u, what does this guy get us?
About 1/5.
There's a v as well, isn't there?
So v over 5.
And we're going to evaluate it at u equals negative v and to u equals positive v. So it's going to be the integral from v equals 5 to v equals 6. You cancel those two guys out and you get essentially a half with a v in it. Then you replace the u with v, and then you get, and you replace the u with negative v. What does that look like? It looks like v equals 5 to v equals 6. What's the sign of negative? Well, let's do this line. Don't want to do too much. What's the sign of negative 5? Because there's a number, but what is it? Odd even properties. What's the sign of negative 5? Isn't it the negative of the sine of 5?
Negative 0.08.
Oh, that's a decimal. Yeah. Yeah. Bad phrasing of the question. I'm just saying that that's him. Why is that important? I'm just trying to simplify this damn thing. You're going to have a half of this plus another half of this. Doesn't that just give you that guy? That's all I was trying to, it's messy. Right, can I dot that? Isn't it just some, a half v squared sine 5? And then you plug in 6 and 5 and you get some version of sine 5. You know, some multiple of it. There we go. Right, these darn questions are a long, they take a long time. So let's see who we're picking. I'm going to pick an easy one. I don't know if I did this. I get deja vu a lot with these questions. This is a version of 8. We have a double integral of a region R. It's 4 lots of x take away 8y. And on the bottom, it's 6x subtract y. And it has a dA. And the region R is described in, oops, this guy goes to this guy, line, this guy goes to this guy. This question is actually nice and easy. You remember that previous one? I had to do that, convert it to that, and then figure out what that would look like in terms of u and v. Not this time. But I do need a u and a v. And if I pick the right u and v, this is going to become dead easy. There are a lot of clues. Who should u and v be?
U is 6 minus 8y, and v is 6x minus y.
It makes sense that those two guys are very good candidates for the u and the v. Let's see how that translates. Well, the region R, if I'm going to call this guy u and this guy v, won't the limits of integration be u equals 0 to u equals 2. And for these guys, it's just going to be v equals 6 to v equals 8. So do you see how the region, I could do it by algebra. I don't actually physically draw the thing. I can just use this. Does that seem reasonable? Now, I have a 4. The other clue is here. Would you agree that that guy and that guy are very good candidates for the u and the v? I'm calling the top one u, calling the bottom one v. Now, we do need to do the Jacobian. And we're finished, right? So I'm going to move this guy over here. And since I know what u is, and I know what v is, and I want to find the Jacobian, which is this guy, can't I just find this Jacobian instead, and then just turn it upside down, right? Use the shortcut. Because in this form, isn't this Jacobian easy to get? Otherwise, wouldn't I have to solve for x and y, and that's a pain. So what do I get? I get 1, -8, 6, -1. Major diagonal is -1 plus 48. So that makes it 47. So the Jacobian I want is 147. Are we comfortable about where the 147th came from? Now, since it's positive, I'm going to use that. So my integral is basically 6 to 8, 0 to 2, 4 over that guy, u over v, du, dv. Can I dot that guy now? I just thought so. Is that guy variable separable? So maybe I should have paused a little bit and said v equals 6 to v equals 8. Oh, let's stick the 447s totally outside everything, right? So what am I going to get is I'm just going to have a 1 over v dv. And then I'm going to have a u equals 0 to u equals 2 over u dv. Would you agree that'd be much easier to deal with now? Get an answer, and then take care of the 447s when you're finished. Now, that one was much cleaner. If you can avoid having to do this into that and then creating the equation, as we could in this question, I strongly suggest you do that, right? You only should do the work that you absolutely have to, especially creating the region S from the original R. Are we good in that answer? Okay. Where am I off to next? I got my notes for the next one. Okay. We got a horrible one. Wait a minute, I just did that one, didn't I? That's good. New guy in town. Who shall I pick? I'll come back to that one. I want to jump around a little bit. Try to find an easy one first, or at least one similar to the one we've done. Right, this is question 13. It's a double integral of a region R. It's 9 x plus y e to the power of x squared take away y squared dA. And the region R is described as between all of these fellas. Now, I hope you can see a little deja vu in this one. What would region S look like? Well, don't we need to know who U and V are going to be? Now, there's a bit of a clue here, but there's much more of a clue here. Can you see who the U and the V are going to be by using the restrictions that R was using? And so when I look at that, what I see is this guy here is U. And this guy here is V. Now, what that will do is it'll make the S guy, right, the guy that goes here, the S, he is now going to simply just be U equals 0 to 4 and V equals 0 to 8. Agreed? Now, the 9 is still 9. The X plus Y is a V. We have a problem with this E guy. We're going to have to put in a Jacobian. And then we're going to finish with the du dv. So I have a problem with x squared minus y squared, don't we? Because that has to be turned into u's and v's. And we have a different problem with the Jacobian. Let's do the Jacobian first. Would you agree this is linear? Can we use the linear shortcut trick to get its Jacobian? In other words, we find that Jacobian. And what does that get me? It gets me 1, -1, 1, and 1. Which if you do a little major, take away minor, you get 2, which makes that Jacobian a half. So we've taken care of the Jacobian, right? It's a half. I want to take care of this x squared take away y squared guy. And I have to replace it by u's and v's. Now there's a long way of doing this and there's the short way. The long way would be to solve. Find out what x is in terms of u and v and find out what y is in terms of u and v. And that is possible, but it would require us having to solve a system of equations and a whole load of other stuff. Does anybody recognize a different way of writing that might help us?
Wouldn't it just be UV?
Correct. And the reason you've noticed that is that it can be written down as a difference of two squares, and isn't one of them the v and the other's u, so you're right, uv. So we now have all the pieces of the puzzle. Oh, by the way, that's a half, right? So if I take that 9.5 and I stick it outside, just to get rid of it, I'm now left with essentially this fella. Is this guy variable separable?
No.
No. If it had been u plus v, right, a different story, wouldn't I have rewritten that as and separated it? But it's not, so we'll live with that. Let's do the first one.
Didn't you already take out a 9 with the 9 halves?
I did, thank you. Right. Let's look at this guy. I want to integrate v e to the power of uv with respect to u. So that's going to be v e to the uv times something. Times what?
V.
Be careful.
1 over V?
Yep. I made that mistake yesterday. I fixed it this time. So that means we have 9 over 2, the integral from 0 to 8, e to the uv from u equals 0 to u equals 4 dv. And that becomes, what do you get? You get 4v and nothing. So it's going to be e to the 4v, take away e to the nothing, which is 1 dv. Can I just dot that now? Because we're pretty much finished. You happy with that guy? Some questions, the choice of u and v are in the equation. Some questions, the choice of u and v are in the boundary conditions that make up the region R. I guess in this case, it was a bit of one and a bit of both. It wasn't most of the information here. That was 13. Where am I off to next? I don't know where I'm off to next. I'm going to jump up to 11, I think. Different type of question. We have region R. And we have 5x squared dA. And the region R is described as an entire ellipse. And 16x squared plus 9y squared equals 144. That is an ellipse. We're actually being told who x and y are. That's good news. So I need to figure out who S is, right? What happens to this when you turn it into UV world? Well, since this is an entire ellipse, can't I just substitute X with this guy and Y with this guy? And what that tells me is it's 16 lots of 3u squared plus 9 lots of 4v squared is 144. And can you just trust me that that ends up being u squared plus v squared equals 1? That's 144 u squareds. That's 144 v squareds equals 144. We got this guy. So we have a double integral over some region S, which is basically a circle in UV space, right? In fact, more than that, isn't a circle of radius 1 in UV space. 5x squared becomes 5 lots of 3u squared. We have a Jacobian to fill in with. And then we can do du dv, right? In this particular question, since you know x and y, I'll probably do this as a side piece of paper then. Since I know x is 3u and y is 4v, can't I just get the Jacobian the usual way without having to do any shortcuts, right? Because it's the right way around. So what do I get? Well, I get 3, and nothing. And then I get nothing and 4. So major takeaway minor gives us a Jacobian of 12. So back to here, we have the region S. That's 9, so I guess that's 45u squared. That guy's 12. That guy's du dv. I'm not going to risk 1245s in today. And that's 540, which I'm going to pull out. So I'm trying to find a double integral of this circle, right? The region inside this circle of this formula. I am not going to do my little vertical line and do u equals the square root of this to u equals the square root of that. That is really ugly and really messy. Can't I do a change in, no, I guess you call it change in variable. We just happen to use a different word. Can't I turn it into polar? I mean, isn't that a really good question when the region is a circle to use polar? Now, in this world, it's not x and y, it's u and v, but can you pretend the u is like an x and the v is like a y? Then in this case, won't u be r cos theta? And won't v be r sine theta? And that means my integral will go from theta equals 0 to theta equals 2 pi. From r equals 0 to r equals 1. That will generate the unit circle. The u squared will become r squared cos squared theta. And then won't you just do an r dr d theta? Although we're not looking at it that way, isn't that really just a double change in variable? You did a change in variable to get uv and then a change in variable to get r theta. Right, can I just say ... in this because we've done enough polar in our work life to know how to tackle it. Any questions?
Can I see the Jacobian one more time?
The Jacobian, this fella? Yeah, okay.
The back page.
Here we go. So in this case, since you've told me in the form that's actually helpful, I'm just going to do the unaltered Jacobian, right? So if you differentiate this with respect to u, you get 3. And then you differentiate this with respect to v, there isn't any, so 0. Then you do this with respect to u, there isn't any, 0. And then this with respect to v gets you 4. And the major take away the minor gets me to 12.
Thank you.
Right. We're cool with the ... Okay. I forgot what question that was. That was like 11. Do another one like that. I think they've got one more somewhere if I look for it. Here we go. Kind of working backwards. This is a version of 10 then. Keep getting deja vu. Double integral over a region R, 9. The sine of x squared plus y squared. No, it isn't. It's the sine of 9x squared. I'll rewrite that. It's 9 times the sine of 9x squared plus 100y squared dA. And the ellipse that we're dealing with is 9x squared plus 100y squared equals 1. Now, in the one that we just finished, they told us the x and the y. In this question, it's very similar. We got one added problem. We have to figure out who the x and y is. Let's see if we can see how the 3 and the 4 happened here and use that to figure out what's going to happen here. Now, do you notice that the x was 3u? But when you look at the x squared, there isn't anything with a 3 and it isn't the 3 squared over here. On the other hand, y is 4v. Well, if I look at the y, there isn't a 4, isn't the 4 over here? So what I'm noticing is that this guy here, right, matches with the y's, and the y's match with the x's. So this guy, 10u, and this guy, 3v. Does that make sense? How I chose that particular u and v rather than anybody else? So I kind of used a similar question. Now you might think, well, how's that going to help? Well, let's find out what this looks like, right? When you convert it into this fella here. Well, it's going to be 9 lots of 10u squared plus 100 lots of 3v squared equals 1. And that's going to be 900u squared plus 900v squared equals 1. I like that, but not the way it's written. Just one more line. How could I rewrite that?
E squared plus b squared equals 1 over 900.
Now, it's not the nicest circle in the world, but would you agree it's a circle whose radius just happens to be a really tiny number, 1/30th? I don't care if it's, I like it if it's 1, but can't I do a radius of 2 or 2/20ths or 2/90,000 whatevers? Now, I went back to the question and they told me something that I didn't pay attention to, so now I am. It's not the whole ellipse, which would be that. It's only this corner, which means it's only this corner. So, our double integral over the region S is going to be 9 times. And when you do this particular transformation, you're going to have the sine of, let's just do it. It's 900u squared plus 900v squared. They're going to be a Jacobian, and then they're going to be a du dv. And the Jacobian is coming from, take that outside. The Jacobian is going to be from here. And again, it's a good one that I don't need to turn upside down. So differentiate with respect to u, you get 10. Differentiate with respect to v, you get 0. Differentiate with respect to u, you get nothing. Differentiate with respect to v, you get that. And this guy ends up being 30. So I have a double integral over S. I have a 9. I have the sine of 900 lots of u squared plus v squared. I have a Jacobian of 30. And I have a du dv. So what's that? 270. The sine of 900 lots of u squared plus v squared. Du dv. Since this region S is a quarter of the circle, can't I just do r equals 0 to r equals 1/30th? And can't I do theta equals 0 to theta equals pi upon 2, and that'll get me this fella. And then I can turn everybody into polar. Which actually I shouldn't have written that until I did the polar, but too late now. Won't u squared plus v squared be r squared times r dr d theta? Now this particular integral can be done as a variable separable, but if we focus on this guy, the sine of 900 r squared times r dr, what calc2 method am I going to use to integrate that ugly guy?
U sub.
And the u sub will be 900 r squared. And good luck. You're going to have some really ugly fractions. Will you agree there's no way of avoiding it? But that's going to be the question. So we turned it into UVs, and then we discovered that the region S was better designed as a polar coordinate question than it would have been to leave it as a UV question. And I believe that's the only two questions that do that. So where am I off to now? Done that one.
Wouldn't you be able
Question.
to sub u squared plus v squared in that one? If it was so it'd equal 1/900 before you convert.
Right. I didn't catch the beginning. What was it you were saying again?
Couldn't you sub the u squared plus v squared is the 1/900 there?
And just make that a number?
Yeah.
That would be good if we were only doing the boundary, but we're also doing all the points inside. So we have to keep it as a general expression. It's not true that u squared plus v squared will always equal 1 or 1/900. It is true that on the boundary it is, but would you agree that this point here, which is also in the region S, is at that point not going to have that property? Technically, it's u squared plus v squared less than or equal to that. Right, so no, is the short answer. We're not allowed to do that. You can incorporate the boundaries. They can use numbers, but not the expression inside. That has to be done as a general, in this case, UV. Okay. Are we good? You may have to think about that. I think I got time for this guy. Be really nice if I did. Question 14.
Should we do
So
attendance now?
Oh, yeah, thank you. Do attendance while I set this guy up. For the last one today, we have this double integral. I know what x and y are, so that's great. Unfortunately, R is one of these regions. So if you take your two equations, I need to find out what region S is going to be. Now, I know what the x and y coordinate of these points are. What I don't know yet is who the u and v are. And this is all I've got to work with. So I try as best I can to avoid this process, but I can't. I got to do it. So this is going to be called 1/5 u plus 1/5 v. And this is going to be called 1/5 v take away 1/5 u. So I have x equals this, I have y equals this. I'm going to call them equation 1 and equation 2. And what I'm going to do here is I'm going to solve. I'm going to find out what u is in terms of x and y and what v is in terms of x and y. And the reason I need to do that is so I can find these damn guys. I don't need it for this. I don't need it for the Jacobian. I only need it to figure out what the new region is. And I'm not even going to bother drawing what that one is because I'm only interested in what this guy is. Any suggestions for what I could do here?
Do you add them together?
And if you add them together, you get x plus y. And it will equal, well, I believe it's these two that cancel. So what do you get? You get 2/5 v, which means that if you multiply both sides by 5/2, I now know what v is. So that's what I mean by solving the equation in this time for v. Now, how am I going to find out what u is then?
Plug that back into another equation.
So I'm going to put this fella. I'm going to plug it into, it really doesn't matter who I plug into. Let's plug into 1. So it's going to be 1/5, oops, it's going to be x equals 1/5 u plus 1/5 v. X is going to be 1/5 u plus 1/5 of 5/2x plus 5/2y. So 1/5 u ends up being 1/2, oops, plus 1/2 x, 1/2 y. If you subtract it from both sides, you get 1/2 x, take away 1/2 y equals 1/5 u. And then if you multiply everybody by 5, you now get u. U is 5/2x, take away 5/2y. Now, the reason I needed to get these is to do the transformation from whatever this is. It's probably a parabola into whatever it turns into. So here we go. -2a. God in Himmel, this